This problem deals with finding the derivative of this product of these functions at 0. So our function f of x is x times x minus 1 times x minus 2, etc. until x minus 100. We want to find the derivative of this point at 0. So here, to find the value of this derivative, we have to differentiate. And we have to differentiate this function here. Okay? So there is a quick way and there is a longer way. Okay? So if we apply the rule, okay, it would be longer, okay? But there is a trick that we can use here, okay? So we know that f prime at 0 is, let me see here, f prime at 0 is the limit as x goes to 0 of f of x minus f of 0 over x minus 0, which is x. Okay, so here this is very, very nice. And we know f of 0, okay? F of 0 is easy, okay? Because here, if we plug 0 instead of x, we get f of 0 is just 0. Okay, so the problem is getting easier now. The limit as x goes to 0. So I can plug my expression for f of x as x times x minus 1 times x minus 2, etc. until x minus 100 over x. Okay? And the f of 0, I get rid of it because it's 0. Now I can, since the limit goes to 0, I can, it doesn't reach 0, but I can simplify here by x to get the limit as x goes to 0 of x minus 1 times x minus 2 times x minus 100. And when I plug 0 here, I can, this is a polynomial, I get minus 1 times minus 2 times minus 100. I have 100 minus sign, and that's minus 1 to the power 100 times 1 times 2 times 100. So this is just 1 times 100 factorial. And therefore, f prime of 0 is just 100 factorial. Okay? So the factorial is a product. Okay? 3 factorial is 3 times 2 times 1. Going this way. Okay? 5 factorial is 5 times 4 times 3 times 2 times 1, of course. Okay? And the hard way is to differentiate this function. Okay? If we try to differentiate, okay, you will get the result, but it will be longer. So the best way is to apply the definition, okay, on this function and get the result very quickly. And that's what I did here. Okay? Here, if we try to differentiate this one, we will get, first, we're going to differentiate x and keep x minus 1 times x minus 2 until x minus 100 constant. Therefore, I will get this result here. So f prime of x will be x minus 1 times x minus 2 times x minus 3 times x minus 100. And plus x times x minus 1 times x minus 2 until 100. Until the last one, which is going to be x times x minus 1 times x minus 2 times x minus 99. Because my last derivative will be for this one, which is going to be 1. Okay? Now, if we plug, okay? If we plug the 0, okay? If we plug the 0, all these terms will be 0. Those having x in the front. So this will be 0. All these last term except this first one. Okay? This first one is x minus 1. Let me move here and write it because it's not clear. So f prime of x will be x minus 1 times x minus 2 times x minus 100 plus the other ones. Okay? The other ones, they have this x that I can factor by. Okay? So when I plug the 0, so I have f prime of 0 is minus 1 times minus 2 times minus 100 which is 100 factorial, as we did. But which one is quicker, which one is easier? I think here this is the quickest way. I believe this one is longer. Okay, but anyway, learning both, and maybe there is another way too. Okay, there is a third way, and it's the one that I like in some cases. Okay, it's taking the log, assuming that the log of f exists. In this case, we're gonna have the log of x plus the log of x minus 1 plus the log of the x minus 100. Okay, and this is the natural log of f of x. When we differentiate, we will get 1 over x plus 1 over x minus 1 plus 1 over x minus 100. Okay, and this one here, it's gonna be f prime of x over f of x. Okay, once we multiply here, okay, we will get this first part. The others will be 0. Okay, but this is useful if instead of computing f prime of 0, we want to compute f second of 0. Okay, try to do this and see which way is the best. Okay, using the definition, the trick, or the log. Okay, sometimes dealing with this one, we can use the exponential and make it easier. Anyways, thank you very much.